Chapter 4.4 is solving radical equations and inequalities. So we've been doing things with expressions, meaning it doesn't have an equal sign, and now we're going to put in equal signs and actually solve for x. So first of all, equations with radicals that have variables in their radicands are called radical equations. Okay, an example of a radical equation is right here. Okay, so like I said before, we have a radical expression, but this time it equals something. Okay, so let's look at an example. The main thing, the first step that you do, the main thing that has to happen before anything else is you've got to make sure the radical is on one side of the equation all by itself, if you can. Okay, most of the time you can. I'll show you the exceptions here in a second, but this is what we have, okay? So this first one, I have a term, and it's already, the radical term is by itself already. So I don't need to do any shuffling around here. But I still do need to get the radical by itself. So I'm going to divide both sides by 2, and I get the square root of x plus 1 equals 2. Now, how do I undo a radical? It's like subtraction and addition go together, multiplication, division go together. Taking the square root of something and squaring something undo each other. So to undo this radical sign, I need to square both sides of my equation. So that makes the radical sign of my square go away, and I've got x plus 1 equals 4. Subtract 1 from both sides, and I get x equals 3. Okay, and if I put that in, I have 3 plus 1 is 4. The square root of that is 2. 2 times 2 is 4. All right, over here, let me see if this works, if this marker works any better. Over here, again, we need to get this radical by itself. So I'm going to add 1 to both sides. So I have the cube root of 2x minus 9 equals 3, and it's by itself. So if I'm taking the cube root of something, to undo that, I need to cube it. Okay, so this undoes that. So I've got 2x minus 9 equals 3 cubed, which is 27. Add 9, I have 2x equals 36. Divide by 2, and x is 18. All right. So I want you to go ahead and try these as soon as I do this. All right, so go ahead and give these a try. Okay, so again, we need to get our radical by itself. Okay, so I'm going to add 9 to both sides, and I get the cube root of x equals negative 6 plus 9 is 7, right? No, how did I get that? 9 minus 6 is 7. Did you know that? Okay, it's 3. So now, when I cube 3, I get x equals 27. All right, so if I take the cube root of 27, that's 3. 3 minus 9 is negative 6. Okay, over here, the radical is already by itself, so I just need to get a new marker. Oh man. Square both sides, okay, and I get x plus 25 equals 4. Subtract 25 from both sides, and I get x equals negative 21. Okay, so hopefully that is what you guys got there. All right. So far, I hope you think that they're pretty easy. They will get a little trickier. One thing that happens sometimes, though, is we have something called an extraneous solution. And this is in your book. And I'm going to give you my definition here in a second, which is much easier than this. But raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. These solutions are called extraneous solutions. And extraneous is fun to say. You know you want to say extraneous. Good job. Okay, when you use this procedure, you should always check each apparent solution in the original equation. Okay, so in other words, an extraneous solution is a solution that doesn't work. So for example, here I have the square root of x equals -3. Now hopefully you'll look at it and go, well, that's impossible. I can't take the square root of a number and get something negative. But let's say I don't see that. And I go, okay, well, I just need to square both sides. And I get x equals 9. Okay? Now when I put that back into my original equation right here, I get the square root of 9 equals 3, not -3. Okay? So this doesn't have, it appears to have a solution, but it actually doesn't have one. All right. So we will do more of these in the next video.